Welcome to Lecture 3. We continue to talk about the theme on declaring PLSQL variables. We will explore the fundamentals of programming in PLSQL.
Today we will talk about large object data types in PostgreSQL. LOB data types are used to store large data, such as text, images, videos, and audio. They allow efficient and flexible access, even when working with very big files. There are four main types. First, file. It stores large binary files outside the database, in the operating system. Second, blob. It stores binary data inside the database, for example images or videos. Third, clob. It is used for large text data, such as documents. And finally, nclob. It stores large text in national character formats. Most of these types can store very large amounts of data, up to terabytes. LOB data types are essential for modern applications working with multimedia content. Now let's look at an example of using clob in PostgreSQL. First, we create a table called impinfo with an employee ID and a text field of type clob. Next, we declare variables. Here, pixel is a clob variable and numpid is a number. Inside the begin block, we create XML data as a large text string. This XML contains employee details such as first name, last name, phone number, and email. We convert this text into a clob and store it into the variable pixel. Then, we insert this data into the table. After that, we commit the transaction to save the changes. Finally, we can select the data from the table to verify the result. This example shows how clob can store structured large text data like XML. Now let's talk about type and row type attributes in PostgreSQL. First, type. It allows us to declare a variable with the same data type as another variable or column in a database table. This helps make our code more flexible and easier to maintain. If the data type in the table changes, our variable will automatically match it next, row type. It is used to declare a record variable that represents an entire row of a table. This means the variable will contain all columns of that table as a single structure. This is very useful when working with multiple fields at once. In summary, type is used for single values, while row type is used for full records. The %type attribute allows a variable to inherit the data type of a table column automatically. This makes your code more flexible and easier to maintain, since you don't need to manually define types. In this example, the variable name gets its type from the last name column of the employees table, and job gets its type from job ID. The %row type attribute works differently. It allows you to declare a variable that represents an entire row of a table. Here, remp contains all the fields from the employees table. Then we assign values to the variables and store them inside remp. Finally, we output the result using dunce output. And that's how %type and %row type help you write cleaner and more reliable PostgreSQL code. This script demonstrates using type and row type attributes in PostgreSQL. It declares a constant date and variables for first and last names. It calculates the number of days an employee has worked since their hire date, outputting the result with the employee's name. A constant holds a value that remains unchanged once declared. It specifies a name, data type, and value, allocating storage. The not-null constraint can be imposed. Declared with the constant keyword, it requires an initial value that cannot be altered. In this PostgreSQL block, we declare a constant pi and calculate the radius, diameter, circumference, and area of a circle. The radius is set to 12 bis, resulting in a diameter of 1 tos, a circumference of 12 tos, and an area of 16 bis. In PostgreSQL, we declare variables with specific data types and initial values. Here, we have a department it's set to use department name as its support, employee name Karen Colmenares, and location details Geneva, Switzerland. These variables are output using dunce output line. In PostgreSQL, we declare variables using the declare keyword. Here, sname is a varchar yike, date is a date, and nage is a number. We assign values and use DIMS output put line to display. My name is Tom. I was born in Nürnberg, and my age is 130. In PostGL, declare variables using the declare block. Here, bonus is a number with precision, and nebit is initialized to just. The select statement calculates a 1 bonus from the employees table, storing it in bonus. The output is just. In PostGL, variable naming conventions are very important for writing clean and readable code. Developers often use prefixes to quickly understand the purpose of a variable. For example, the prefix is used for standard variables. So, when you see a name like Vempno, you immediately know it is a regular variable. Next, the prefix is used for constants. Constants are values that do not change during program execution. For example, xisdate represents a constant value. Another common prefix is p. It is typically used for parameters or SQL+ variables. This helps identify values that are passed into a procedure or script. Finally, the prefix is used for global variables. These variables can be accessed from different parts of the program. Using naming conventions makes code easier to read, understand, and maintain. It also helps teams work more efficiently together. In PostGL, naming conventions play an important role in improving code readability. They help developers quickly understand the purpose of each variable. Commonly, we use prefixes. For example, this used for variables, is used for exceptions, t is used for types, p is used for parameters, and t is used for constants. These prefixes make the code more structured and easier to follow. We can also use naming conventions based on data types. For integers, we often use names like int or int. For strings, we use str. This way, we can immediately understand what kind of data the variable stores. Overall, consistent naming conventions help maintain clarity, reduce errors, and improve teamwork in development. In PostGL, the into statement is crucial for assigning column values to variables. For example, use select employee id into nid from employees where first name Steven to store Steven's employee id in the variable nid. In PostGL, the DIMS output package is used to display messages from your code. It is especially useful when working with stored procedures and functions. The main purpose of DIMS output is debugging. It helps developers see what is happening inside the program while it is running. The most commonly used procedure is putLine. It prints a line of text to the output buffer. There is also put, which writes text without moving to a new line. To control output, we use enable and disable. Enable turns on the output buffer, while disable turns it off. We can also read data from the buffer using getLine and getLines. These components work together to manage how messages are stored and displayed. In summary, DIMS output is a simple but powerful tool for debugging and understanding your PostGL programs. The enable procedure in the DIMS output package activates output to the buffer and sets its size. The buffer size can range from equal to infinity, with a default of if unspecified. For example, use DIMS output enable to set a specific size. The disable procedure in database management system output is crucial for managing output. It stops all procedure calls within the package, clears the buffers, and resets the buffer size to its default. Use the syntax database management system output disable to implement this effectively. The put procedure in DIMS output places a string into the buffer without adding a line feed. It converts data types like number and date using the toucher function with default formats. Syntax DIMS output put hep all Oracle ru. The put line procedure in DIMS output is similar to put, but it appends a new line character to the string. This means each call to put line results in a separate line, unlike put, which builds a single string. Note that the string length is limited to circa 2 bytes. The getLine procedure retrieves a single line of buffered information. It uses the syntax DIMS output getLine Lines out varchar status out varchar. This allows for efficient handling of output in PostgreSQL by capturing one line at a time. The getLines procedure retrieves multiple lines from a buffer, unlike getLine. It uses the syntax divens output getLines, lines out char numlines in out integer, or deems output getLines, lines out deems output lines array, numlines in out integer. This script demonstrates using deems output putline to insert messages into a table. It creates a table of dupst, enables database management system output, and inserts a line with status into dupst. Finally, it commits the transaction and selects from dupst to display results. We declare a variable sumsal to store the total salary. The department number is set to alps. Using a SQL query, we calculate the sum of salaries for employees in this department and output the result using deems output putline. Thank you for listening. We appreciate your time and interest in this topic.